In today's lesson, I wanted to have a look at free body diagrams. So vector diagrams, just to quickly go over your vector diagrams, they are blocks that you then draw your forces from. So a little bit different to a free body diagram. So if I just have a block being pulled on a horizontal surface, the forces that I'm going to have is my FG, and you'll see my FG I always draw from the center of my box down, and my normal force is always perpendicular to my surface, and it starts from the surface, so from the bottom of the block, not from the middle like the gravitational force. And then you would have your F tension this side, or your force applied going that way, and then your force of friction is always in the opposite direction to your direction of motion. So if I had to draw the free body diagram for this specific block over here, I'm going to show my block as a little dot in the middle, and then my normal force going upwards, my FG going down, my applied force, and my frictional force. Your forces need to be in relation to each other, so my FG is maybe a little bit too short because it's not moving vertically. The FN and the FG perfectly cancel each other out. If they say to you that it needs to be a named free body diagram, you have to go and write your keys. So then you have to go indicate what those forces are that you refer to. Alright, so just be careful. If they say they want a named free body diagram, then you have to go and do this. Put a little key on the side so that you can indicate exactly what it is that you are showing. Alright, so that's as if it's just on a block or on a normal table. If my box is on a slope like this, let me just draw it nicely. If it's on a slope like this, we have to remember that my FG is always going to be from the center straight down. And my normal force is always perpendicular to my surface. So this is essentially my Fy component. My Fn is going to be exactly the same as my Fy, right? And the Fx component, so this component over here, is the force of gravity that pulls it downwards. Alright, so if we had to go and do the free body diagram for this one, you have two options. They will generally usually count for 3 marks. Let's say there's a force pulling it up like that. So you can choose which one you want. Your first option is to draw your FG down. So your FG is down. Your normal force is always perpendicular to the surface. Then you've got your F applied going this way, and then you have your F friction going this way if there is friction being applied on the box. If you don't want to draw the gravitational one, you're going to still make your dot. You're still going to have your normal force going up that way. You are still going to have your force applied over there. You are still going to have your frictional force this way, but you're going to have an additional force going over here. So you're going to have a force going there and a force going over there. So this is going to be your FG perpendicular, and this one over here is going to be your FG parallel. So this is the components that you're going to be using. So you have the option to either do it like this or like that. And then remember, if it's named, you need to make sure that you're including your key on the side with everything that it is called.